Hello dear students, welcome to Wallah English channel. We are studying signals and system in comprehensive manner. Already total we completed 23 lectures in this course and this is lecture number 24. So just we have started classification of signals, and in last class we have seen odd and even signals. Okay. So first of all, tell me all of you in comment box, am I audible properly? Audio and video both are clear to you people? Tell me in comment box. Okay. So let us continue further. Now we will see the question in discrete time for odd and even signal. Discrete time questions. Okay, we are studying odd and even signal classification, odd and even signals. Now check the symmetry of the given signal. X of n is given 2 1 1 1. Here so first folding with respect to y axis, n become minus n. N become minus n means starting from last to first. So here 2, the next is 1, then again 1, again 1, then this is 2. Okay, and here there is no change in the position of origin. So as you can see here, is x of minus n become x of n. That's why the given signal is even symmetry. Yes or no? Even symmetry. And suppose graphically if you want to see the even symmetry, then it looks like this. At origin amplitude is 1. Then next also 1. Also 1. Two. There also 2. You can check the symmetry. 0, 1, 4, minus 1, minus 2, minus 3, minus 4. Here amplitude is 1. This is correct. Also 1, also 1. Now folding with respect to y axis, you will get x of n only. So this given signal is what? Even signal, even symmetry, or you can say symmetrical with respect to y axis. Here, tell me, symmetrical with respect to y axis. Fine. I hope all of you are getting what I am saying. Here. Very good. Now next question. See. Next question, guys. Check the symmetry of this signal. So again, n become minus n. N become minus n. Starting from last. So 3, then 1, then 0, then minus 3, then minus 1. What? Time reversal operation. 0. So this is not equal to x of n. This is not equal to x of n. So here there is no even symmetry. Not an even signal. Now amplitude reversal. So minus x of minus n. you have to change amplitude of, or we can say sign of each and every sample's amplitude. This is 3, amplitude reversal means -3. Here is -1, this is 0. Okay, this is 3, this is 1, which is equal. Now you can see here this first time reversal and amplitude reversal, which is equal to x of n. Here there is odd symmetry or odd signal, anti-symmetric odd signal. So here graphically, if you want to see, so at origin 0, next right side 3, then 1, here it is -3, -1, 0, 1, 4, -1, -2, minus, is here 3, 1 is -3 and -1. Now see, first folding with respect to y-axis and folding with respect to x-axis, amplitude reversal, you get this same x of n. That's why given signal is odd signal. Here voice is too much low voice. Now check once, all of you. Now audible properly? Tell me guys. Now audible? Now please check once. Okay, fine. So here odd symmetry is present. First folding with respect to y-axis, time reversal, then folding with respect to x-axis, amplitude reversal. Correct? Now next, question number 3. Now check symmetry of this signal, odd, even or nano. Check the symmetry of this signal, odd signal or even signal or nano. Odd, even or nano. Which type of symmetry? Even symmetry is there. Even symmetry. Odd symmetry. Even symmetry, odd symmetry or nano. See here. X of minus n. See, you are saying -2, -1, and this is 2 and 1. From this only we cannot say whether this is a odd symmetry. Okay. See the odd symmetry here. Simply see -1, -2, then at origin 3, this is 2, this is 1 at origin 3. This is what? Amplitude, time reversal, which is not equal to x of n. That's why there is not an even signal. Now amplitude reversal, you have to change sign of each and every sample's amplitude. So this is 1, this is 2. Now you can see at origin -3. This is -2, -1, and you can see here. This is also not equal to x of n, and this is also not equal to x of n. That's why this is what? Neither even nor odd signal. If it is odd signal, then odd signal has amplitude 0 at origin always. Odd signal has, whether it is in continuous time or discrete time, odd signal has amplitude 0 at origin. At origin, you can see here. This is the odd signal, so at origin amplitude is 0. Why? Why? That also I am telling. So here neither even nor odd, neither even nor odd signal. Here, tell me. Done? Very good. Now see why it is. How to find the odd signal? Odd signal is given by x of n plus x of minus n whole divided by 2. Now, if you want to calculate the value at origin, n equal to 0, x of 0 plus x of minus 0 whole divided by 2. Now, plus 0 and minus 0 both are same. So, odd signal value at origin, nothing but this is x of 0 plus x of this is also 0 whole divided by 2. Now, this is 2 times x of 0, 2 get cancelled out. So, here sorry minus sign. Here this is odd signal minus. Okay. Now, x of 0 minus x of 0, it is 0. So, odd signal has amplitude 0 at origin always. The important result. What about for the even signal? It is even signal x e of n, then x of n, now plus x of minus n whole divided by 2. We want to calculate amplitude at origin, n equal to 0 plus x of minus 0 whole divided by 2. Here it is 2 times x of 0, correct? Because x of 0 and x of minus 0 both are same, plus 0 minus 0 both are same, divided by 2. So, here it's important. So, even signal has value at origin same as that of the original signal x of n, correct? Fine. So, this is very much important result. They can ask in multiple select question also. Done? Okay. I hope all of you are getting. Let us take one more question. Try this question. Check the symmetry of the given signal and find its even part and odd part. If it is nano, then find its even part and odd part. Find its even part and odd part. Find the even part and odd part. If it is nano, odd, even, and nano. tell me, this is odd or even or nano signal? Expecting answer from each and every one. Of course, this is what, guys? X of minus n of minus 10, 4, 3, 2 and 1, which is not equal to x of n, correct? Is not equal to x of n, and do the amplitude reverse also, that is not equal to x of n. So given signal is what? Nano, neither even nor odd. Okay. Now if he wants to find it's a even part and odd part, then first of all make the equal number of samples, right side of the origin, left side of the origin. Make the equal number of samples before finding odd part, even part. What exactly I am saying, guys? The x of n equal to, here see, right side there are two samples, so left side also it should be two samples. So 0, 1, 2, 3, make equal number of samples. Left side, right side, equal number of samples. Equal number of samples not there, then add 0 like this. Then next is x of minus n required to find its odd part and even part. So minus n required. This is again 0. Time reversal. And this is 4, 3, 2, 1. Okay. Now, how to find even part? Even part formula is x of n plus x of minus n whole divided by 2. One part is 1 by. See here. Now time by time you have to add the samples amplitude and divided by 2. So 0 plus 4 divided by 2. It is 2, guys. Here 0 plus 4 divided by 2, 2. 1 plus 3 divided by 2, again 2 plus 2 divided by 2. Okay. 3 plus 1 divided by 2, again it is 2. 4 plus 0 divided by 2, it is 2. Clear? So this is what even part. And how to find its odd part? Odd part is given by x of n minus x of minus n. Now subtraction, whole divided by. So odd part is, now subtraction, see, 0 x of n minus x of minus n. So 0 minus 4 divided by 2, that is minus 2. 1 minus 3 divided by 2. So 1 minus 3 minus 2 divided by 2, that is minus 1. 2 minus 2 divided by 2 is equal to 0 at origin. 3 minus 1 divided by 2, which is equal to 1. And 4 plus 0 divided by 2, that is 2, guys. So again you can see here odd signal has amplitude 0 at origin. So this is the odd signal. But is clear how to find the even part and odd part of discrete time signal? Very good. Now next question. Now try this question. Find its odd part and even part. Of course, this is nano signal because right side only one signal, one sample, left side 3 samples. Okay, so definitely it will be nano, neither even nor odd. Now find its even part and odd part. I am expecting answer from everyone. Again, the given signal is nano, neither even nor odd. Now x of minus n. So first of all, make equal number of samples both. Equal number of sample means x of n. Right side only one sample, left side 3 samples. Minus 2, 2, 1, 3, 4, 2. Now 3 sample, 3 sample. Okay. Now time reversal, x of minus, it is 0, then 0, 4, 1, 0 and minus 2. Four, then 3, then 1, 0, minus 2. Now for one part, x of n plus x of minus n divided by 2. Minus 2 plus 0 divided by 2 minus 1. 0 plus 0 divided by 2. 1 plus 4 divided by 2, 5 by 2. 3 plus 3 divided by 2, 3. 4 plus 1 divided by 2, 5 by 2. Okay. 0 plus 0 divided by 2, 0. 0 plus minus 2 divided by 2, minus 1. Okay. And here, now odd part. Odd part is given by subtraction, x of n minus x of minus n divided by 2. Minus 2 minus 0 divided by 2, minus 1. 0 minus 0 divided by 2, 0. 1 minus 4 divided by 2, that is minus 3 by 2. 3 minus 3 divided by 2, 0. 4 minus 1 divided by 2, by 2. 0 minus 0 divided by 2, 0. 0 minus minus 2 divided by 2, nothing but 1. Clear? And again you can see at origin amplitude is 0. Here to each and every student. Here guys, fine. Okay. Now next question. Number 6, Q of n. So tell me, Q of n is a right sided signal. So of course, all the right sided or left sided signals are always nano. Got neither even nor odd signal. Nano. Neither even nor odd signal. Fine. Nano signal. So find its even part and odd part. Its even part is given by Q of n plus Q of minus n whole divided by 2. Okay. So U of n plus U of minus n. Already we have seen it is not 1 for all n. At origin, see at origin amplitude of this is 1. At origin amplitude of this is 1. So 1 plus 1 divided by 2. So at origin 1 and other than origin you will get 1 by 2. At origin 1 plus 1 divided by 2, that is 1, and other than origin amplitude is half 1 by 2. Here this is 1 by 2 by 2. So 1 minus 1 minus 2 minus 3. Okay, the even part. And I am talking about the odd part. Odd part, Q of n minus Q of minus n divided by 2. Okay. So here it is. At origin of course 0, I told you guys. Origin 0. Origin amplitude is 0 and other than origin here 1 by 2 by 2 by 2. Here guys, minus 1 by 2, minus 1 by 2 by 2. Here. Origin 1 by 2 minus 1 1 minus minus 3. This is the odd part, and this is even part of u of n. This is clear to each and everyone? Fine. Yes. Okay. Now next question number 7. So x of n. Now see, this is what complex number, guys. Okay. Now this is what complex. So for complex number, how to find even part and odd part? For complex number already I told you guys. If it is complex value signal, is complex value signal xe of n equal to x conjugate of minus n. X of n is x conjugate of minus n. It is conjugate even, guys. It means conjugate even, same as continuous time, and x of n equal to minus x conjugate of minus n. It is known as conjugate odd signal, conjugate odd. Clear? Now how to find its even part? Conjugate even part is given by x of n plus x conjugate of minus n divided by 2, and its odd part given by x of n minus x conjugate of minus n whole divided by. Fine. Now see, so here complex value signal minus 2 plus j2, this is minus 2 plus j2 again. So this is what, guys? Complex value signal. Okay. For complex value signal, symmetric condition is, again see, right side 3 samples, left side 0 samples. So again it is neither conjugate even nor conjugate odd, and one part. So first of all, make equal number of samples left side and right side. X of n equal to 0, 0, 0 is n minus 2 plus j2, this is again minus 2, then this is also minus. Okay. And at origin 10. Now x of minus n first, right? X of minus 10 means minus 2 plus j2, then minus 2, then minus 2 plus j2, then 10, okay, then 0, okay. Now see here, complex value signal, that's why conjugation also required. Conjugation means plus j become minus j become plus j. This is minus 2 minus j2, is minus 2 minus j2, 10, 0, and 0. Now you can find it's an even part and odd part. For even part, x of n plus x conjugate of minus n divided by 2. So 0 plus this divided by 2, that is minus 1 minus j. 0 plus this divided by 2, that is minus 1. 0 plus this divided by 2, that is minus 1 minus j. 10 plus 10 divided by 2, 10. Sample is at origin. So this sample will be at origin. So minus 2 plus j, 2 plus 0 divided by 2, minus 1 plus j. Minus 2 plus 0 divided by 2, minus 1. Minus 2 plus j, 2 plus 0 divided by 2, that is minus 1 plus. Okay. So this is the conjugate even part, and conjugate odd part is 1 by. How to find the conjugate odd part? Conjugate odd part is subtraction x of n minus x conjugate of minus n divided by 2. So 0 minus this divided by 2, that is 1 plus j. 0 minus minus 2 divided by 2, that is 1. 0 minus minus plus 1 plus j. 10 minus 10, 0. Minus 2 plus j, 2 minus 0. Minus 1 plus j. Minus 2 minus 0, that is minus 1. Minus 1 plus j. So again you can see here at origin amplitude is 0. So this is the conjugate odd part and conjugate even part. Here, fine. Okay. So I hope all the students are getting this clear to each and every student for the complex value signal, symmetric condition. Now to find conjugate even part and conjugate odd part. Now suppose graphically x of n is given and they are asking to find its you have to check the symmetry of this signal. You have to find its even part and odd part. Try this question. So you can write this in sequence format and you can solve in the sequence format, and then finally you can draw graphically. I'm expecting answer from each and everyone. So odd signal or even signal, nano signal. So right side 3 samples, left side only 1 sample. Of course it's a nano. Here the given signal is neither even or odd. So you can write this in sequence format. X of n is equal to. So first sample should be non-zero, last sample should be non-zero. Left hand side, right hand side equal number of samples. Prefer left hand side, right hand side equal number of samples. So here 3 samples. So here also 3 samples take 0, 0, 0, 0. This is 1. At origin 2 guys, correct? Next is minus 1, minus 1, minus 5 and 8, correct? So 3 samples, 3 samples. It will be very much easy to calculate odd part and even part if there are equal number of samples both the side. Okay. Now let us calculate even part. First of all, you require x of minus n. X of minus n equal to 8 minus 5 minus 1 1 0 0. Okay. X of n even part. Now real value signal 0. 0 plus 8 divided by 2 4. 0 minus 5 divided by 2 minus 5 by 2. 1 minus 1 0 divided by 2 0. Correct. 2 minus 2 1 plus minus 1, that is 0. 2 plus 2 divided by 2, that is 2. Correct? Minus 1 plus 1, minus 5 minus 0, that is minus 5 by 2. Minus 5 by 2. 8 plus 0, that is this. You can see this is the even signal. How to calculate odd part? Odd part is given by x of n minus x of minus n divided by 2. So 0 minus 8 divided by 2, that is minus 4. 0 minus 5 divided by 2, that is 5 by 2. Then next 1 minus 1 divided by 2, that is 1. 2 minus 2 divided by 2, that is 0. Minus 1 divided by 2, that is minus 1. Minus 5 minus 0 divided by 2, minus 5 by 2. 8 minus 0 divided by 2, that is 4. Okay. So this is the odd part. This is what? Odd part. Clear? Okay. So if graphically x of n is given, then write it in the sequence format, and then you can follow the procedure, and graphical representation you can do it for x of n and x o of n. Clear? So in this way we can find the even part, odd part for the discrete time also. This is, I think, very much easy with compared to the continuous time. Fine? Clear? Now important result, this is very much important result, guys, that you have to remember. First result, already I told you, first result. First of all, I will write for the continuous time, then I will, first of all I will write for the discrete time, and same thing, continuous time first of all we write, and same thing applicable for the discrete time also. So what is the value of all odd signal at origin? At origin, first result, and value of one signal at origin is nothing but same as x of t value at origin. Already we have seen. Fine. Now third important result, guys, integration of odd signal from minus infinity to plus infinity. Answer, tell me. 0 or non-zero? Integration of odd signal. Suppose this is the odd signal. The odd signal. What is the area? Integration means integration minus infinity plus infinity means area under the odd signal. What is the area? Total area of odd signal. 0 or non-zero? Tell me in comment box, all of you. Area of odd signal is 0 or non-zero? Tell me, each and every student. Area under odd signal is, what is the area of this odd signal? 0 or non-zero? Is 0 only always. Correct? Similarly, what is the area of even signal? Of course, it will be non-zero. Suppose even signal. One signal. Okay. So if you want to calculate area of this signal, then what you can do? Area, total area minus 1 to 1. So if you find the area from 0 to 1 and you make it double, then you will get a total area. So you can write like this. It is nothing but 2 times area 0 to infinite, because area from minus infinite to 0, which is equal to area for 0 to infinite. Simply you can find the area for half limit and you make it double, find the total area. So integration 0 to infinite 2 times 2 times xc of t dt. Here, fine. So this is the fifth result. Now next important result. We know that any general signal, sum of its one part and odd part. Now if you calculate the area of this x of t minus area of x of t. So here integration minus infinity xc of t dt plus integration is a linear operation. You can separate the integration. Already we have seen the area of this area under odd signal is 0. Under odd signal here area of odd signal is fine. So we can write like this number, result number 5, that is area of x of t, area of any signal x of t dt equal to area of its even part. So area of its even part, which is equal to area of the signal x of t. Okay. They can ask in multiple select question, out of 4 statements, how many statements are true. So again 2 times 0 to infinite of t is very much important. Clear? This is the result number 5. Now suppose you integrate minus infinity to plus infinity square, after taking the square, then it will be minus infinite plus infinite. Let me write this in next page. Integration after taking this square, which is equal to integration minus in x e of t plus x of t square, which is equal to integration minus infinity plus a plus b whole square, that is a square plus b square plus 2ab x e of square t plus integration minus plus infinity square of t plus 2 times minus infinite plus infinite x of t not of t. Okay. Now see here, square of the even signal is even. Square of the even signal is even. Square of the odd signal means odd into odd also even. Correct? Square of the odd signal is even. Now here, this even signal multiply with odd signal. So the resultant signal is odd and area of odd signal is 0. Area of odd signal is 0, guys. So that's why the answer for last term is always 0. So finally result number 6 is integration minus infinite plus infinite x square of t dt equal to area of its even part square plus area of its odd part square. Now see, can we say this is nothing but the energy of x of t? Can we say this is nothing but the energy of its even part? Can we say this is the energy of nothing but its odd part of x of t? So again, one more result from this, energy of x of t given by energy of its even part plus energy of its odd part. Okay, so these are the very much 7 important results. Okay, these are the very much 7 important results for the continuous time signal. Okay, fine, for the continuous time signal. Now same thing we can see for the discrete time also, guys. Discrete time. So important results for the discrete time. Again, first is x origin. Value at origin is 0 for part. Okay, and one part got value of x of n at origin. Clear? Now result number 3. Instead of integration, summation of discrete time odd signal. Tell me. Summation of discrete time odd signal is always. You can see from the examples also, guys. You can see from the any example. See, this is the odd signal. What is the summation of all the samples? Summation, if you do the summation of odd samples, odd signals, -1 + 1 0, -5 by 2 + 5 by 2 0, 4 - 4 0. So summation will be always 0. Correct? Summation will be always. That's why you can write like this. And fourth number, I would say very much important. Summation of even signal, n is minus infinite. So even signal, same as the continuous time, there is little change. Here see, in the continuous time, we have seen that 2 times 0 to infinite x u of t dt. But here you can see, guys, the discrete time, see, this is the odd signal, correct? This is the, sorry, this is even, this is even signal. So even signal, so see, this is summation for n equal to 1 to infinite. Summation for n equal to 1 to infinite, and summation for n is equal to -1, minus infinite to -1. So can we say summation from minus infinite to -1 is equal to summation from n is equal to 1 to infinite will be same. Summation from n equal to 1 to infinite, n equal to -1 to -infinite will be same. So we can write like this, 2 times summation n equal to 1 to infinite and plus x of 0, guys, plus x of 0. This is nothing but origin, x of 0. So what exactly we can say? Here we can write like this, discrete time. Discrete time, the important result is here simply x of 0 origin value plus times summation n is from 1 infinite x of n. Is this clear? Correct? In continuous time it was 2 times 0 to infinite x e of t dt, but in discrete time it is x of 0 plus x e of 0, x e of 0 plus 2 times summation n equal to 1 to infinite x e of n, guys. This is also very much important result. Now fifth result, summation of, here fifth result was integration area under x of t is nothing but area under of its even part. Again here also same thing applicable, same thing is applicable. Result, summation of x of n equal to summation of its even part. Okay, and from here we can write like this, x e of plus times summation n is 1 finite x e of n. Even we can write like this, see this. Okay, the x u of 0 is nothing but what? X of 0. You can write like this, but of 0 plus times summation n is 1 finite of n. So this is very much important result. Fine. Okay, they can ask in multiple select question also. Is clear to each and everyone? Tell me in comment box, all of you. Clear or not? Yes or no? Result number 6. Summation after square operation. Summation one part plus summation of its odd part. Okay. So again you can see here, this is what energy of x of n, and this is energy of its even part, and this is the energy of its odd part. So result number 7 you can write like this: summation of energy of x of n signal is equal to n signal equal to energy of its one part plus energy of its odd part. You see like this? Yes or no? So these are the very much important result for the continuous time odd even signal and discrete time odd even signal. Is this clear or not? All of you tell me in the comment box. So this is number 7. Fine. Done. Nikhil, tell me. Confirm whether this is clear or not. So this is all about odd and even signals. Now next classification is periodic and aperiodic, or we can say non-periodic signal. So first of all we will see the periodicity for the continuous time signal, then we will see for the discrete time signal also. Okay. So let us start. X of t, let us consider x of t is a continuous time signal. Then the signal x of t is said to be periodic if it satisfies, or if x of t is equal to x of t plus or minus k into capital T, like this. If any signal satisfying this condition, then it is said to be periodic signal, where k is any integer value 1, 2, 3, 4, 5, 6, and capital T is known as a fundamental time period, or we can say periodicity of the given signal for which this condition is satisfied. Okay, where we can say x of t equal to x of t plus or minus into capital T, where k is any integer value, integer only, okay, any integer, and capital T is known as the periodicity, or we can say the fundamental time period, or cycle for period for one cycle. Okay, here it is fundamental time period. Fundamental time period. Like if k equal to 1, then t plus or minus t, k equal to 2, then t plus or minus 2t plus or minus 3t, so on. Okay. So here there are two types of periodic signal: non-sinusoidal periodic signal like square wave, triangular waveform, sawtooth waveform, and sinusoidal periodic signal like sine and cosine. Correct? There are two types of periodic signal. So we will, here in this question they will ask, check whether the given signal is periodic or not, and if it is periodic, then find the fundamental time period capital T, or the sinusoidal periodic signal and non-sinusoidal. So first of all let us discuss for the non-sinusoidal periodic signal. Suppose this signal is given. The question is find the fundamental time period of the signal x of t. So as you can see here, periodic signals are everlasting signals. Means it should be periodic from t equal to minus infinity to t equal to plus infinity. Correct? You cannot say the signal is periodic for the limited time of period, like right side periodic or left side periodic. Periodic signal should be periodic from t equal to minus infinity to plus infinity, and then it is said to be periodic. Correct? So here this is what periodic signal. So see how to find the fundamental time period. Fundamental time period cycle. This is the first cycle. First cycle. Okay. So time period for one cycle, and this pattern is repeating, guys. This pattern you can say repeating. See, minus 6 and 0. So pattern exists between minus 6 and 0. Same pattern exists. Same pattern is present between 2 and 6. Correct? That's why you can say this is the periodic. Periodic. And what is the fundamental time period? The fundamental time period. You can say fundamental time period t equal to 6. From minus 6 to 0 you can take, or you can take fundamental time period from minus 3 to plus 3 also, guys. This is also one cycle, you can say. This one is the positive half cycle, this one is the negative half cycle, and fundamental time period T. Fundamental time period capital T here, and it is nothing but what? Fundamental time period capital T equal to 6. Here you can check. Here you can check, guys. X of t plus, suppose k equal to 1. Equal to 1. So plus or minus t. This x of t plus or minus 6. T plus or minus 6. So right shift by 6 unit or left shift by 6. Suppose right 6 by 6. Then this point will come at here. Point will come at here. Point will come at here. So x of t plus capital 6 is nothing but what? Or t minus 6 overlapping the original x of t. So in short, this signal is satisfying this condition, which is equal to what? X of t only. So that's why the given signal is periodic. And what is the unit of this fundamental time period? The unit is second, and the frequency, fundamental frequency, guys. F is nothing but what? Fundamental frequency. Fundamental frequency. F is nothing but fundamental frequency, and F is nothing but inverse of the fundamental time period. So what is the unit? Second inverse, or the well-known unit is hertz. Okay. Or we can say it is we can say cycles per second, number of cycles in 1 second, or latest unit is hertz. Correct? Capital T. So unit is, we can say, second inverse. The frequency second inverse. Old unit is cycles per second, and the latest we are using hertz or kilohertz, megahertz, gigahertz, like that. Okay. Now omega also frequency, guys, but this is the angular frequency. What? Angular frequency. Omega is equal to what? Pi f, and the unit of nothing but what? Radian per second, because unit of 2 pi theta is nothing but radian, and here unit of f is per second. It is radian per second. Omega is equal to pi by capital T. Okay, angular frequency. This is normal frequency in hertz. So this is your periodic signal with the fundamental time period 6, and the fundamental frequency is f equal to 1 by 6 cycles per second. That means one cycle, we can say in one cycle there are only 1/6 frequency or 1/6 cycle per second. Okay. Now next question. Suppose this one, guys. Find the fundamental time period. What is the fundamental time period? Whether it is periodic or not? Yes, this is also periodic. You can see What is the fundamental time period? Fundamental time period is from here to here, you can from 3 minus 3 pi positive half cycle, negative half cycle, correct? From minus pi to 3 pi also you can take. Minus pi to 3 pi also fundamental time period. This is your fundamental time. From here to the fundamental time period is 4 pi. The fundamental frequency course of this. Second, in this all are what, guys? Non-sinusoidal periodic signal. Okay, non-sinusoidal periodic signal. Fine. Just we started the next classification, that is periodic and okay. So let us finish this lecture here, guys. All of you, thank you so much watching me live on Get Wallah English channel, and please provide your valuable feedback after completion of the session. Next part will continue into subsequent module. Thank you, guys. Thank you so much.